Today, we are going to connect a powerful cloud-based reasoning engine directly into your own localized permanent memory vault. By giving your AI a local agentic memory, you solve the context window problem. It stops forgetting specific workflows, your personal coding habits, and your project history the moment you close the session. By the end of this setup, you will have a functional Gemini 3 Pro command line interface. It will be linked directly to your local MemPalace and guided by your own custom system prompt. Before we configure the engine, check your environment for these 4 items: a Linux terminal with Node.js, a Google Cloud Platform account, the Gemini CLI, and a local installation of MemPalace. Gathering these tools upfront ensures a clean installation. Building an independent AI workflow requires precise routing from the very first step. Step 1 is building the project container. Open the Google Cloud Console, click the Project Picker in the upper left corner, and create a new project. Cautionary note: the difference between the project name and the project ID. The system needs the project ID. Copy the specific alphanumeric string highlighted here and save it. With your project selected, click the terminal icon in the upper right to open the Google Cloud Shell. We need to activate the machine learning backend by enabling the AI platform APIs. The command is gcloud services enable aiplatform.google.com project equals your project ID. Swap the placeholder for your actual project ID. This activation is necessary to route local requests through Google's cloud-side processing engine. Next, navigate to the Gemini admin settings URL for your project. If you see a gray banner prompting you to enable required APIs, click the blue button and wait for the page to refresh. Scroll down until you find the section titled Release Channels for Gemini Code Assist in Local IDEs. Change the selection from Generally Available to Preview and save. You can leave the development tools logging empty. This setting expands the range of available models, giving you access to Gemini 3.1 Pro. Standard commercial models often lack the specific reasoning capabilities needed for agentic workflows. The preview channel provides the model depth necessary to handle long-term memory integration. Now we link your local environment to the cloud project. Open your Windows PowerShell in administrator mode. Type WSL and hit enter. Inside your Linux environment, type nano./bashrc to open your profile. Scroll to the very bottom of the file. We are adding your Google Cloud Project ID as a local environment variable. Paste the configuration text into the bottom. To save and exit, press Ctrl-O, Enter, and Ctrl-X. Run source/set/bashrc to refresh and load the new configuration. With the environment variables active, your local terminal is now authorized to securely communicate with your cloud project. To specify which model the CLI should use, open nano/set/gemini/settings.json. Paste the required routing configurations and save the file. Next, we bind the Gemini CLI to your local MemPalace. We do this by adding MemPalace as your designated model context protocol server. Cautionary: when inputting the terminal command, do not blindly copy the file path. Replace the user placeholder with your actual WSL username. If you installed MemPalace in a non-default directory, adjust the path to point to your specific MemPalace MCP file. Accurate MCP routing is essential. This file path provides the direct bridge between the AI's reasoning engine and the directory where your data is stored. To define the AI's persona, create a text file named GEMINI.md in your settings directory. Enter your foundational system prompt here. Now, initiate the application by typing npx at google/Gemini CLI in your WSL terminal. The system prompt file acts as the set of instructions for how the AI handles its connection to your memory. Look for 2 confirmations on the boot screen: a successful load of your Gemini.md file and a status message confirming the MCP server is running. You can switch models at any time by using the /model command directly in the chat interface. You now have a personalized AI agent that processes logic through the cloud while maintaining a permanent, localized context. This setup allows for advanced automation, where your primary agent can direct secondary local models to execute tasks based on your stored data. Setting up independent AI systems requires careful manual configuration. If this guide saved you time, consider supporting the research to keep the lab running.